Hi, we're here to see Dr. Albrecht.
Alright, please take a seat and I'll let her know. Thank you, Pet.
Hi, Mrs. Head. How you feeling today? I'm good. Alright, we're going to go ahead and do a blood test and see what's going on. Alright, I'm going to take this back for testing, and I'll be back with the results. Okay. Mrs. Head, I'm sorry to tell you, you have hemophilia! No! I'll give you a moment alone. Here, have a tissue.
How can this be?
It's okay, Mrs. Head. We're going to get through this. I'm going to bring in our best genetic counselor, Dr. Keating.
Thank you, Mrs. Albrecht. Hi, I'm Dr. Keating, your genetic counselor.
Hi, I'm Maggie. My daughter Kristen just stepped out. She can't handle this.
I understand. Dr. Albrecht? Alright, you were diagnosed with hemophilia. I brought along these Punnett squares here that I'll show you the possible genotypes for Kristen and the probability of her chance of carrying the disease or possibly having it. Hemophilia is basically a disease where your blood doesn't clot or coagulate, if you will. It doesn't matter the size of the cut either. It could be a paper cut, a knife stabbing, a shark bite.
Here's a little bit of history of hemophilia. So royal family carried it, but back then incest was not uncommon. So the recessive gene that carries hemophilia was more common to go throughout the members of the family.
So will I die from that?
No, not unless you bleed out uncontrollably. Alright, let's talk about Kristen for a minute. Do you know if her father has the disease or carries the gene for the disease itself?
I'm sorry, but he's no longer with us.
Oh, I didn't mean anything like by it.
Oh no, honey, we're just divorced. Hemophilia is a recessive trait, and because you have it, you have two homozygous recessive alleles.
Hello, what?
Homozygous means that you have the same types of alleles, and because it's recessive, you are homozygous recessive.
Therefore, if your husband was also homozygous recessive, Kristen would have a 100% chance of getting the disease. Since you both are, you would pass both recessive alleles along. Here I have a Punnett square explaining the chances of Kristen either having a trait or carrying it. Along the side is the homozygous recessive. That's you. Up at the top is her father, who would be heterozygous or just a carrier. She has a 50% chance of just being a carrier, and she also has a 50% chance of actually having the disease. This is the second Punnett square I have for you. Along the side again is you with the homozygous recessive. Up here is the father with the homozygous dominant. That means he doesn't have it at all. Therefore, Kristen would have a 100% chance of just being a carrier. Unfortunately, since you don't know the genotype of the father, you'll have to get Kristen tested. We can get Dr. Albrecht to take her back there and get a blood sample if you'd like.
Okay.
Okay, so the blood results came back for Kristen, and she is negative.
Yes!
Woo!
Yes! Yes!
She is negative. She is kind of
Yes! You hear that? Mom? Do you hear that? Carrier!
Meaning that she's only a carrier.
Yes!
So the only thing that we need to worry about now would be if she has children.
Woo!
She would just need subject because you do still have hemophilia.